it comes.
Yeah, I get it. We were getting the smoke there from Utah and the California fire, so it was looking like a war zone for a day, but then the winds blew it out. So this morning was a beautiful sunrise. So that's a good thing in a way. So all right, we're gonna get started. Hopefully we'll get more people logged in. We had 40 some registers, so hopefully they'll log in. We sent them a reminder already. If not, good morning, good afternoon for all of you. My name is Tony Salas. Welcome to the Diesel Roundtable, the early August edition, because we have a later August edition, which is going to be with Kelly from Promax Tools later on this month on the 19th. So we'll be doing that. Obviously, those of you that may be watching the recording, because I have to teach live and the recording too as well, please note that we're going to have more roundtables September. We're going to have hopefully Dynamite Diesel. We got other speakers lined up. So hopefully this thing will continue to grow with good speakers. So there you go. As we get started with Roundtable, first of all, can everybody hear me okay? Because before we had some sound issues. I know that Ivy can hear me and Mara can hear me, but hopefully you can all hear me. So send me a chat message if you hear me. So therefore, definitely want to make sure. So if I don't hear anything, it means you guys got it. So, all right, let's get going with the slides. Obviously, I can move this over for a second. Please note if you want to scan the QR code there, if it's not in the way. We actually are going to have another roundtable, like I just said. There's the link. So those of you that didn't see, because I screwed up on the first email blast where the link was not working, now I fixed the link for the second session. So therefore, if you haven't signed up for the 19th roundtable, or you just want to see the recording, please note that here it is. So therefore, sign up there. I know a lot of you have signed up, but some of you have not. So therefore, there you go. Definitely want to pay attention to that. And then those of you have been asking me for, I've been doing a lot of online trainings. So therefore, some of you have been asking about when are you going to do the Diesel Master course again? I got like 5 people that are interested. We kind of stopped that for about 2 years now. But I'm going to bring it back up this fall, the 5-day Diesel Master course, which is the big 3. Ivy, I know that's not up your line, but we do light duty diesel training. So therefore, that's a 5-dayer. And we got EL1, EL2. I'm going to do it at multiple locations. So since some of you have expressed that I need to do electrical, I need to learn electrical. Definitely, there's going to be an opportunity for these hands-on courses. 2 days for EL1, 2 days for EL2. And obviously, I still have the online diesel training, and we're going to make a Duramax course there too. So therefore, you'll see that up and coming as well. So definitely want to do it because I don't want to spend too much time on my stuff and tooting my own horn, because we got a guest speaker. You all seen her already. This is Ivy Underhill. And Ivy, I'll have you, usually I introduce people and tell them what to do and what your experiences and everything else you do, but we're going to let you do that, and you could tell her how famous and how popular you are. But one thing that I met Ivy back at the, as you can see in the picture, I met Ivy at the diesel, what was it, the competition there. And we were working the electrical station, and she was doing her station too as well. And one thing that caught Ivy was the way she started talking about electrical. And it's always nice to see that I'm not the only instructor out there that, and Ivy, you could probably understand this. For us, for me at least, one of the hardest classes to sell is electrical. But obviously, what's the most needed, it seems like. I mean, I don't know if you agree or disagree, but it's electrical. So when she started talking about her things with, and like you just mentioned earlier about relays and talking about circuits and how these guys don't test properly and so on, I'm like, gee, I'm not the only one. Nice to see that, you know, this is a big issue, because when you come across technicians, and I get all these Facebook postings from other instructors and also diagnostics scenarios that other instructors do, and you see that the problem was a battery, a connection, or poor ground, and they spent hundreds, if not thousands of dollars in parts. I mean, Jesus, that just gets on my nerves sometimes, and it's not fair to the customer. So anyways, enough of that. But yeah, we got electrical coming up, guys. But obviously, Ivy's going to talk about her thing too as well. So Ivy, first of all, let me stop my share. And I'm going to go ahead and let you put yours up there. So let me hit stop share. And there you see the rest of us there. So Ivy, you can go ahead and share your PowerPoint. Just hit the share button on the top and you can share your thing there. So
there we go.
There you go. And yeah, there you go. I guess we're good there. So
my name's Ivy Underhill. I'm one of the trainers here at Warren Cat. We're kind of over the Oklahoma as a whole territory and then the northern side of Texas. When I say cat, I mean Caterpillar. So a lot of heavy stuff. Not too much of the on highway, but it's really cool seeing the crossover. I've watched a few of the roundtable discussions. And honestly, a lot of the stuff that we're going to talk about today is just the crossover that you guys see. So I know a lot of people see a dozer or a loader or an excavator and go, man, that must be super intense. That is a completely different ballpark. But actually, honestly, a lot of it crosses over. But a little bit about myself. I'm a trainer over here in Oklahoma. I'm on the machine side, so not necessarily the giant engine stuff, mainly the machine. So hydraulics, powertrain, transmissions. We deal with the same things you guys do, and then diesels as well. So don't do too much of the gas tuning. I'm also here with Cody. Cody's one of our newer instructors. He's going to be talking about some of the updates that we have a little bit later in the presentation. Caterpillar's kind of changing their strategy for marketing and their after treatment side of things. So as you can see, we're going to be talking about Tier 4, Stage 5, and we'll have plenty of time for discussion topics and afterwards doing a little roundtable. Some of the stuff that we're going to be talking about, I can't go in depth as much with it because Cat does have some proprietary stuff. So if I can answer your question without stepping on any toes, absolutely, I totally would. But yeah, we're going to dive as deep as we can into it. If you guys do want to see more of the Caterpillar side of things, or maybe you're on the heavy side or deal with some heavy equipment, 100% by all means, we do have training courses that we can give more information at. If you see on the slide up there, we are part of the Warren U training team. So Warren Cat has a separate branch for their training now, and we can kind of give a little more information, things that we can't give on this as well. So I'm going to go ahead and get started here. So the first thing we're going to talk about is what are our goals through this discussion. So the first things that we want to talk about is what is the purpose for talking about the Stage 5? I mean, everybody has so much fun dealing with after treatment. Why do we bring it up another level? So we'll kind of talk about that. We're going to talk about later the Tier 4, Stage 5 updates that we have coming out with Caterpillar. And of course, the crossovers that we're going to have. So the similarities between on and off highway. So you guys aren't looking at this like, oh man, that's a giant dozer. It's going to operate so much different. Well, there are some differences, just not as intense as some people might think. Some of the new technology, and then again, the roundtable at the very end. So if you have any questions, by all means, I'm here to answer questions as much as I can. Cody's also here. He has some more on-highway experience. So if you know something a little bit more, ask the question. If we can answer it without stepping on any toes, absolutely we will. So we'll go ahead and get started here. So Tier 4 final is what we use in the states. Stage 5 is what they use in the EU. So what is it? How does it work? EPA, everybody loves this, the Environmental Protection Agency. They've set regulations throughout the years, changed a little bit here and there, kind of started really on the off-highway stuff in the mid-1990s, really got put in stone relatively recently. So like I had said before, the EU kind of started with stages, and they kind of worked into it a little bit quicker than we did with getting those emissions and the standards we have to hit higher quicker. So in 2019, in January, they actually started on their Stage 5, and I'm pretty sure in the past 2 years after that, they are standard across the board. You have to hit Stage 5. And I'll show you guys here a little chart about, what kind of changes with the Stage 5. But here in the US, we're Tier 4 final. We're not changing from it. There's been no talks about changing away from Tier 4 final, moving to anything else. And I'll kind of talk about why Caterpillar's changing. But Tier 4 final, that's where we're at. Let's go ahead and look at some of the charts here that we have. So here's the guidelines. This is just a little quick chart that we made up showing the differences in the particulate matter that we're allowed to produce. Same with the hydrocarbons and the NOx that we're allowed to produce. And as you can see, over time, it goes down. So the stages Like I was talking about before, in the EUs, they use stages. If you want some crossover, the stage 3B is the tier 4 interim that we have, and the stage 4 crosses over for our tier 4 final. The next level that we have is that stage 5, of course, that's Europe-based. It is not coming to the US again, so don't be worried. On highway, you guys are safe, but Caterpillar switching over, so we just drop a little bit more on our particle count that we can have, the particle matter coming out of it, and our NOx drops just slightly more. Not a whole lot, because we're already reducing the NOx emissions out of our diesels significantly, about 90 to 95%. So we're just dropping that much more on it. So not too much is changing. The technology is changing quite a bit. And we'll kind of get into that a little bit here, and then Cody will deep dive it a little bit further as far as we can a little bit later. But this is what's changing. So if you're curious on why I'm calling it Tier 4 Stage 5, this is why. So why are we switching over? So why can't we just stay Tier 4 Final and, Europe has their own thing? Well, if you guys remember back in COVID, we were having a lot of problems across the board in manufacturing trying to get parts. Not only the electronic portion of it, which Tony, you probably dealt with, trying to get sensors or ECMs or anything really on the electrical side, to even some of our bigger engines we couldn't get a handle on, or even transmissions. So Caterpillar's switching over so we can standardize it across the board. Why don't we just take that engine that we're building for the EU that may be a little bit more efficient, less costly in manufacturing, and standardize it for everywhere? So not only the EU is getting the same thing, but the States is going to get the same thing. And there's actually a lot of benefits to upgrading it. It's not just, oh, well, the EPA isn't changing. We need to, reduce the amount of particulate matter that's coming out of these engines. It actually helps, and we'll kind of talk about that a little bit more down the road, especially when we get to the crossovers. But parts availability is another big thing. If I have a whole manufacturing plant designed for the EU model of engines, and I go, hey, why don't we just build another one in the States? Now, if either one of these plants falls short on how many parts they could produce, now we can help out across the pond, as they say, or across the channel. So parts availability gets a lot better. Same thing with getting ahead of EPA. So we don't want to keep falling behind, and then the EPA goes, hey, we're switching over. Now we have to develop all this new manufacturing facilities, all this infrastructure to just keep up with the response. So we're getting ahead of the EPA. So in case 20, 30 years down the line, they say, hey, we're going to switch to stage 5, we're already there. We don't have to make any drastic adjustments. We don't have to do the troubleshooting things that we do when we develop new technology. You guys have probably seen that plenty with DEF in the past 20 to 30 years. Whenever they develop a new thing, there's always going to be problems with it. Caterpillar's working on that now. So getting ahead of it while we can. So let's talk about some crossovers, because we know light duty and heavy duty, they might look intimidating, seeing a big old yellow dozer rolling down the road. They are very similar on the after treatment side. So here's just a kind of overview. This is over. So the DEF systems, we have a lot of crossover. I know a lot of the on-highway stuff is built by Bosch, kind of crosses over here. We have a CEM, or clean emissions module, that's similar to any of the on-highway exhausts, and I'll kind of show you some breakaways of that. We call our NOx reduction system, or NRS. You guys might refer to it similarly as a EGR system. Crosses over, kind of similar technology, works a little bit differently. We could talk about that a little bit, but again, CAT has their own proprietary stuff, so I can't deep dive into it too much, but what I can share, I will. So turbo technology across the board, pretty well standard. We'll kind of talk about some of the changes that Caterpillar is doing with Cody down the way, and then fuel systems, a lot of things cross over there, so we'll talk about those. So the first one, DEF. Caterpillar designs their own DEF systems, but Bosch does manufacture a lot of the components. So the pump they make, Bosch makes a really good DEF pump. We use their DEF pumps. Some of the injectors that we use on our systems, and some manifolds we use on our systems. But overall, Caterpillar designs the entire system, and Bosch goes, here's our pump, that'll work there. Here's an ejector, we'll keep up the supply for you. This will work for you. So Some things are going to change with software, of course, but Bosch will manufacture a lot of our components. It takes away some of the necessity of building infrastructure when it's already there. Why reinvent the wheel when you don't have to? And then it's a similar construction. I can't do any breakaways and show you guys where it runs and everything. That's a little bit more on the dealer side of things and the technical side of things, but pretty well the same across the board for DEF systems. So now CEM, or Clean Emissions Module. This is like your guys' exhaust. Back in the day, this is kind of a rough diagram of how ours work. So we get out of the engine, our exhaust gas is flowing through a DOC, pretty much identical to what you guys run into on the on-highway stuff. Then we go into a DPF, then we go into a mixing tube, and then we go to another catalyst to remove the rest of the NOx, and we have clean emissions. So really similar here. We kind of change how it's laid out on some of our machines. I know doing some research on the on-highway stuff, it might be reorganized a little bit, or we might call things different titles. So mixing tube, you might hear of decomposition tube or mixing pipe, tons of different names for them. So, but pretty well standard across the board. This is our clean emissions module. Then we have an NRS, very, very, very similar technology to an AGR. We are taking that inert gases that's in the exhaust, rerouting it to the inlet side of the engine, and displacing some of that air going into the engine, reducing the NOx that's generated in emissions. So very similar. Cody's going to talk about a little bit more about the technology and what we're doing with this, but eventually you won't be able to see one of these on a machine, hopefully, but I'll let Cody deep dive that here in a little bit on it. So NRS, pretty well similar, a little bit different technologies to the on-highway AGR. Then we get turbos. This is the fun ones. This is the wastegates. Tony, you've probably dealt with. I got head gasket leakage happening, and then you walk up and there's a hose clamp on the dang wastegate. So never have to deal with that, but we deal with the same thing. So over here we have a wastegate turbo. To the right of it, we have a balancing valve turbo. Works kind of similar, a little bit different technology. From what I hear, it's not too common on the on-highway stuff. A little bit of different build on our machines, but that is a balancing valve turbo. And then we also have the twin scroll turbos. And of course, this is newer to the Caterpillar side. On highway, I hear about a little bit here and there with the asymmetrical and the symmetrical turbos, but Cody is going to deep dive a little bit of our strategy behind it. Again, Cat confidential. I can't tell you guys everything, but we do have classes on some of this stuff if you guys would like to attend one of those in the Oklahoma area. So here's the turbos that we use. Next is fuel systems. Now, without getting too in depth with these, we have just about the same fuel systems or injectors that you guys have on the on-highway stuff. And I love to say these fuel systems. You have the EWI, the HUI, and the MUI, which is absolutely my favorite, but the electronic unit injector. Then you have the hydraulic electronic unit injector, and the MUI, the mechanical electronic unit injector, which personally is one of my favorites because you only see it on the big engines. Big engines sound really cool when you step on the accelerated pedal. And then lastly, the common rail, which is not new technology by any means, but is one of the newer stuff that we're putting on our machines pretty well across the board on our medium to small range. So common rail, again, kind of works the same way. So don't be intimidated by those big machines and the fuel systems they have. They work about the same way, still high pressures on there. And then we get to the differences. So the first thing to start out with, on highway versus off highway. Here's a chart of some of the things that change here with the regulations. Really, the main one here is our NOx. And what we're looking at there is a difference between the working conditions practically. So as you know, on highway, we're running for long distances or maybe shorter if you're in a little smaller of an area. But long distances is pretty well consistent across the board what kind of emissions that engine's going to put out. It's not going to be as drastic as, say, something like a loader shoveling dirt into maybe a rock crusher, or you have a dozer maybe leveling out a plane and it's just going forward, pushing a ton of dirt, and then coming back and restarting that push. So a little bit different there. Then we have excavators as well. You're digging, it's going to constantly be changing the emissions coming in and out of that, or going out of that engine. So a little bit different on the regulations here. Of course, thankfully, the EPA saw that and made a little bit of adjustments here. So if you're looking at this, you're like, I wonder why the NOx can be a little bit more than on highway. It's because of the volatileness of the engine. So, but that's some of the differences just in the standards. And here's our clean emissions module. So from the research that I did, we only have one component really that changes from on highway to off highway. So same thing here. And of course, there are plenty of videos on these roundtables. If you wanted to know more about what the DOC, the DPF, and the SCR do. But in here, same thing, we run into our DOC on here. We're going to start getting rid of those hydrocarbons, start increasing our EGT on our machines, and start getting some of that soot to burn out of it. Then we have the DPF. So we're going to hold any soot until we hit regen, or it's going to convert that soot that's inside of it into ash. After that, the last little bit of exhaust gases is going to run up into a mixing pipe, mixing tube, decomposition tube, whatever you'd like to call it. That's where we're going to inject our DEF fluid into our exhaust. Then we have this long tube, so we're going to mix it all up and then put it into our SCR, another catalyst. That's really going to take down all the NOx that's coming out of our emissions. And of course, if you've ever had to start doing troubleshooting, you know the DEF system is always playing a game of keep up with our emissions. As we talked about, NOx is coming up, going down, left, right, all over the place. It is never really consistent. It doesn't know, hey, in an 8-hour span, if I'm working hard, I only need to use a gallon of DEF. It doesn't know that because it's constantly changing with load. We have another filter here called the MOX. It's an ammonia filter. Its job is to take any extra DEF and break it down. So now we're not adding that ammonia into the atmosphere. We're not producing a new emission. So that was about the only real difference that I see on the CEM module with the change from on highway to off highway, but pretty well standard across the board. And Cody's going to be talking about some of the new technology that we have and what we've done to kind of reduce the amount of weight on our machines, but I'll let him talk about that. So here's the differences on our CEM. And then we get into some of the CAT proprietary stuff. So I can't deep dive into this too much, but the increasing the EGT, we have a little bit of a different strategies with it. I know a lot of times, like on your newer diesels on the on-highway, you'll have a 7th injector on there, which so much better than hydrocarbon dosing. But we use similar technologies. I just can't get into too much information on those. Sadly, Caterpillar puts all their confidential stamps on everything. So our fuel strategies are pretty well similar. Main thing, the difference is on there is that we're going to have different load environments, different operating environments on highway versus off highway. And then our NOx reduction technology. I'll let Cody talk a little bit more about that in the update. So I'll go ahead and pass it off on to you, Cody, for the updates.
All right, thank you, Ivy. So first off, we're going to go and we're going to start talking about twin scroll turbos. So Caterpillar is running on their next gens. They're running a asymmetrical turbo. Cylinders 1 through 3 feed the small scroll. Cylinders 4 through 6 feed the large. Just like blowing through a straw, it's going to create back pressure, but it's also going to increase the pressure putting on the turbine wheel. So the benefits, you're going to get the benefit of a low pressure turbo and a high pressure turbo through this asymmetrical. So I know some of the Dodges, Cummins, stuff like that, they run an asymmetrical turbo. This is newer to the CAT. So putting a load on cylinders 1 through 3 via the back pressure is going to help with spool time. It's going to help with throttle response. It's going to help decreasing the NOx because you're going to spend less time spooling, trying to put more fuel to the engine. And next, we're going to talk about weight saving. So all of our CAT equipment, big, heavy, bulky equipment. So we try to save weight wherever we can. So the weight saving on these compact CEMs is coming through losing the ARD head, the NRS, and its cooler. We do increase the amount of def we're using in the stage 5, but that gives us the ability to remove some of the materials that are in our filters, in our clean emission modules. Also, a byproduct of not having an NRS cooler, we're not trying to compensate for that extra heating, so we can actually make our cooling packages smaller as well. Then up next, we have the DEF pumps. So our DEF tanks and pumps are changing. On the left, you see our updated DEF tank and pump. It's a lot bigger tank. We're using double the amount of DEF, but we want to keep your DEF fill-ups in the same intervals. We don't want you to have to fill up twice as much, every day filling up DEF. So we increase the tank size, and the DEF pump is like something you'd see on like a D13 Volvo, the VNRs, stuff like that. It's a very tech-friendly, easy to work on, not very cumbersome. And then on the right, you have our old DEF tank and pump setup. It's a lot more complex, a lot less tech-friendly. You do have a smaller tank because we're not introducing as much DEF. But there's a lot more points to fail on that. There's a lot more connectors, a lot more hoses and lines, more things to go wrong in that older pump setup. So that's just a couple of ways that we're trying to get more modernized and get ahead of the game.
Okay, what questions do you guys have that we could answer? Again, we'll try to give you the best response that we can without stepping on Caterpillar's toes. So, Tony, did you have anything that you saw out of there that kind of shocked you that Caterpillar had, or?
Well, some of the things that it's funny because some technicians want to have the highest, they want the latest in tech information, and it's all nice and dandy. But the problem is, the thing that I see consistently is the fact of the diagnostic approach that they have. That's been a biggie. And those of guys have seen me over and over again. And I even said before in a previous roundtable, I go, I know that I say this all the time, but I consistently see it. It's like, so do you guys come across those things where, you replace a particulate filter, you're servicing a particulate filter, but yet what clogged it is what you need to look at, type of thing? Would you agree? In other words, we got a fueling problem, a turbo problem, or something like that.
Yeah, the fun one that I like to talk about is that when I was a technician working on these things, I had a customer that was complaining that within about 3 hours they'd have their DPF kit clogged up, and so we went through. We actually use CAT ET instead of something like a scanner like your OBD2. We use CAT ET, and it logs in, and we can do a service regen on it that burns. It's a longer regen that we burn out most of the stuff on. And then we replaced it. And then we were like, okay, well, 3 hours, that's pretty quick. Are you doing anything? Are you putting oil in this? And I was watching one of your guys' roundtables previously, and it's like, don't ask them if they are, ask them how much oil they're putting on it. And in fact, we actually had a leak on the turbo, and it was just pouring oil into the exhaust and everything. And it was clogging up real quick and in a hurry when it went to burn those out. So yeah, I mean, a lot of it is just being familiar with the machine, knowing, okay, well, I know how it works on my truck, but yeah, I don't know if it crosses over. Same thing with electrical, you probably run into. It's like a fuse checking on a piece of heavy equipment versus your truck. You're gonna check it the same dang way. Why do I have extra hydrocarbons getting in there, burning up everything? Oh, well, I don't know, man. It's just happening, it's just part of the game, It can't be because I'm having bypassing happening, or you even checking compression at any point to see if you're pulling oil through the rings. I mean, there's just so many things that you can go through. Don't just fix the problem, find why there's a problem. It's kind of thing. So we see that too.
Yeah, because one of the things that, when we got ECM issues and sensor issues, circuit codes and all that happened, the thing is that I tell them when a truck's acting or a diesel engine, it's acting stupid, I say. Something's making it act stupid. And one of the things I always have stressed was, batteries, can say enough about batteries. And even like I've said before, I've had apprentices that work under me here locally, and they're just in awe how many batteries we find bad. And in some cases, that's the issue. And it's been at another shop for over 3 months, and they can't figure out till it comes to us. It's like, really, you didn't see the battery issue? It's like, hello. And then the other thing is, the quality of fuel. Fuel has been a big discussion on social media, what's going on with diesel too as well. In other words, I don't know if you agree, but we have proven it that diesel fuel is not a constant. We have issues with the quality of the fuel. And if you're doing bio stuff and other stuff, it's like, it just makes matters worse. And then you still got these idiots that still believe in using transmission fluid, which today's transmission fluid is, pretty much synthetic. It's like, so that's not the old transmission fluid of the back in the day. So yeah, so I take it you guys see that a lot in terms of even on heavy equipment. So
Yeah, my favorite one is we actually have this kind of case study that we examine when we start talking about contamination in our fuel systems. Favorite part about it is we had a customer, this was years and years ago when we had first started switching over to common rail. And if you've ever worked on common rail, they really don't like any sort of contamination. You need to change your fuel filters whenever services come up. Don't just say, it'll buff out, it'll work, it's fine. But they didn't know that the common rail was such higher of or less, MUI system was a higher tolerance. The common rail was very finicky when you got that junk in it. Well, they were complaining all their next gen machines, they're just failing left and right. And when I say next gen, this is years ago. So they're newer machines at the time, but they were complaining. They're like, I keep having to pay for all these fuel system replacements. My pumps are going out, and then my injectors after that. And we come to find out, they were never looking at their bulk tanks. They were just kept refilling and refilling and refilling and refilling. And if you've ever dealt with bulk tanks getting algae in them, it doesn't just go away. It keeps building up and building up. And that was one of the things. It's like, hey, why don't you check that? Because that's where you're feeding all of your machines. Can you look at that? And it's a little different on highway because a lot of times you're just going up to wherever fuel station. But heavy side, you have a designated bulk tank that might be maintained or could not be maintained. I mean, a lot of your bigger facilities will, but smaller machine operators will let it go until they get to the point of replacing everything. So, yeah, we see a lot of failures.
another thing I wanted to mention, changing the subject, obviously you showed your after treatment system, which all the components are similar to us too. But the one thing that I wanted to ask you about is the ammonia slip. We call it ammonia slip catalyst. That actually is, breaking down the ammonia. I haven't been able to get much technical information. I don't know, Mara, since you're an exhaust person, I don't know if you can chime in, but obviously urea is, in other words, that fluid is 32.5%, urea with water, deionized water. But what exactly are we doing to that ammonia in that catalyst? Anybody can
jump in there.
Yeah, it takes any excessive DEF and basically addresses it so that you're not allowing ammonia to enter the atmosphere. So whatever DEF that the SCR didn't use gets addressed within that ammonia slip catalyst. So then you have water and I think nitrogen or something going, it's non-harmful pollutants. We don't want to be saying, hey, we're getting rid of NOx, but we're sending ammonia into the atmosphere.
Yeah. Real good. It's just breaking down chemicals like Mara was saying. So like when you have your hydrocarbons enter, you're having that reaction with the DOC that causes your increased EGT or exhaust gas temps. You're breaking it apart so it turns into water, and then you have carbon still there. The DPF takes your carbon. So all you're doing is filtering it out chemically. That's why everybody likes to cut the cats off of the big stuff and go try to sell it, because there's really high quality metals in there.
So that's what all the theft is about. But no, I was just curious because also these applications that we have on light duty also have ammonia sensors. And what we've learned so far about these ammonia sensors, because the diagnostic trouble code is like check power and ground to it. Does it do this and that? Then at that point, step 3 is telling it to replace the sensor. And it's like, okay, what are you telling me on how to test that ammonia catalyst? You know, in other words, what do you want me to verify? But then we discussed on a previous roundtable where I found in the GM service information where, you know, a NOx sensor cannot tell the difference between ammonia and NOx. So when we see high consumption of DEF fluid, it's because there's excessive ammonia in the exhaust. So therefore, it's fooling the NOx sensor, in turn causing more DEF fluid, you know, to be reducted, to be injected. So it's like, but the clarity, or shall I say, the information that they're providing us is like, how do we know if I got an ammonia sensor, which is about a $600-700 sensor, and we have this code? It's like, well, maybe it is telling the truth about the true ammonia content. You know, it's like, okay, so catalyst or no catalyst, but it's, you know, it's kind of a pain in the butt to, you know, isolate there. So unless you got some input, I'm willing to listen to. So.
Oh, well, I think the technical term, if you want to throw another acronym in there, is PFM, but it's magic how it works. So that's what we see. Cody, do you see anything online or technical information?
I haven't came across a whole lot of technical information that's not CAT proprietary. On the heavy side as a tech, we really didn't see a whole lot of sensors going bad in that side in the emission module. We did see temperature sensors. You know, you have each individual temperature sensor on a Caterpillar running to its own module before it makes it to the ECM. Nowadays, we're getting away from that. We're going to run the same amount of sensors, all 3, but they're all going to a single. So that kind of makes it easier. You're not having to chase wires like, hey, we're not getting temperature from this sensor, throwing a code for this. So now we just replace all of them, which is kind of a pain, but it takes one step of that troubleshooting out.
Yeah, it's just like something that we're confronted. But you know, Matthew's logged in on here. I see his face there, and Matthew can tell you, you know, Matthew and I have discussed through the past, and you know, we have seen NOx sensor failures, and especially when they're biased. So therefore, it's giving you a certain parts per million reading, but then it's like, okay, is it reading correctly or not? So we have, you know, I've had to come up with magic numbers on light duty side on what are those parts per million, because in our diagnostics, and I guess you can also, it's not hitting on any proprietary, but are you guys also using NOx sensors for fueling, for fuel trim too as well, like we are? In
Not
other
as
words,
much.
because you know the amount of NOx is indicative of if you're overfueling, especially on our common rail systems. So therefore, you know, the NOx sensor is not just a player for indicating NOx reduction and also coming out of the engine, but also an indicator for fuel trims that are we underfueling, overfueling, which in turn will get NOx sensor concentration high codes because of the fact that there's nothing wrong with the engine per se. It's that it's overfueling, which is again a fueling problem, meaning injector / whatever else that affects the performance of that injector, even as frivolous as something as a compression issue. So
Yeah, so a lot of our fuel side of it, so we do have our Caterpillar version of an EGR. We were using that on the old stuff, but on the new stuff, we were able to delete it. Kind of like what Cody said, we're just using more DEF, so we don't have the EGR cooler failures or NRS cooler failures that you guys will normally see, or some of the components on those that fail decent amount of times when you get up in those hours for our machines, or miles probably for you guys. A lot of our fuel software or tuning, it's kind of set by Caterpillar. So Caterpillar goes, yep, okay, when we're at this load, we have the engine working this hard and we have this much power, and our speed sensors will talk to each other to figure out all the load and everything. We actually have a setting per injector that there's a software designated for that injector that goes, hey, this is what you're supposed to do. If you're lacking, we're going to have some sort of way to help that injector. So it's not using it necessarily for the emission side of things where it goes, oh, we're overfueling, now we need to cut back. It's going to do a little bit of a calculation game. This is where ECMs get all fun, kind of like the NOx sensors, where it doesn't really tell you what it's looking for, but once it figures out what it needs to do, it just does it. So like your communication networks, no idea what those zeros and ones mean, but they mean something. And when they don't talk, it's going to cause problems. So that's what we see a lot. We don't see too much on the software or the tuning side of it. We don't really have tunes for our machines.
Very good. Well, I've been doing a lot of talking. Anybody else logged in like to make any questions or comments there before I continue on here?
Yeah, Matt.
Go ahead.
Yeah, Matthew here. The question there for Ivy and Cody. I understand there is things you can't share as proprietary from Caterpillar, but from my understanding, you're getting rid of your any EGR or NRS system on these newer engines. My question kind of is does that mean then you're not only you're adding more DEF as you said, but also you're going to have is your SCR system going to be larger, including having a larger ammonia catalyst too because of all that in order to keep after things is one of the questions I have, and then I have another one or so too.
Yeah. So on our systems, like you were saying, we're going to be taking away that EGR as a whole, and we're using about twice the amount of DEF, which is still not a ton. How we're kind of working with that, we're taking away kind of like what he said, we're losing weight and size off of our kind of CEM or clean emissions module. Our DPF, our SCR, and our ammonia filter are now in one canister. So it's smaller, but they're almost the same amount of size. If you remember back on, let me go back to this picture here. If I can go back, we'll just go back a little bit here. So here you can see kind of the DOCs are smaller, then our DPFs is a lot bigger. Our SCR and our ammonia are kind of smaller-ish. They're all about the same size, and I would probably equate it to about the size of the ammonia filter. But our DPF is smaller so that we can increase the amount of size for ammonia filters on there. But did that kind of answer your question? Or
I think it does. The other thing I think it kind of leads into is my other question. They mentioned about higher EGTs, which obviously with the higher EGTs, you're able to get burn off or even passive regens to be able to get that DPF to burn off better and reduce particulate matter in that whole process is what I'm gathering too. Is that pretty well fair to say?
yeah, so we've actually our strategies are kind of similar on our fuel side of things, using the DOC to react with any hydrocarbons in our setup. There's some technology out there, I'm not quite sure if it's cat proprietary, that we use that's kind of been tuned a little bit better so we don't have as much particulate matter coming into our exhaust. So our DPF's able to be smaller, and then you might regen a little bit more. Like you guys use passive regen a lot. We actually have active regen, and we have set levels that we hit until we start hitting the point where, hey, you need to stop the machine and it needs to run its own regen, really hot regen to burn out all that extra soot that's in. We'll see how that changes with a few years. This technology kind of started in 2020 and really is in the assembly line now. So we'll see how well our regens work going forward and see the cleaning setup that we need to run with those, how long they make it. But it's kind of newer for Caterpillar to have this smaller setup. So.
In relation to those EGTs, and I know you can't give exact numbers, but obviously there's an increase in that. The obviously engine components, turbochargers, all that stuff has got to handle more exhaust temperature too. Which in the light duty stuff that Tony and I are working with, there's been questions at times, where is our safe limits when we're dealing with continuous load, which you guys would be doing with in the in that off highway type thing, where with our light duty, we got these light duty vehicles that some customers aren't getting them hot enough, and others are just taking them to the max. So obviously that level has been raised somewhere in order to handle that extra heat. Can you speak to any of that at all, or is that just something you just can't speak to in terms of EGT increases?
A little bit here and there. I'm not sure what temperatures you guys normally run at for your regens, but I know about 700 is where we start our regen, where we get into it, where we have kind of a passive, and of course it builds over time on that because now we're actually doing a regen. And I've seen temperatures up to 1500, but there is a point where the ECM goes, hey chief, this is too hot, we're going to start melting things, and kind of dials it back. That will change with the different size of engines. So we run the smaller stuff. C7s is probably what you're familiar with on the on-highway stuff. But we have giant engines that are as big as this room that I'm in that will just, eat heat. It doesn't care. So we'll see it change a little bit. Cody, I don't know if you had anything you wanted to add to that about the EGT.
So without having, NRS or EGR, we're not recirculating gases back in. So the heat of the exhaust gases leaving is not as big of a concern. We're not worried about melting pistons as much or anything like that. So they're gonna get hotter than your normal light duty or medium duty trucks. But the fueling and timing strategies that we use are a little bit different from y'all's. We adjust timing and we inject on different strokes in order to build that heat.
Are you referring to pilot injection and post injections?
It would be, I don't know if it's confidential, but it's more of a cylinder injection.
Okay.
So we're injecting on a different stroke in order to push those hydrocarbons in order to build heat without using a seventh injector. There are going to be situations where we do have a seventh injector. That'll be on those fuel systems that can't fire on those different strokes. But without, like I said, without having to worry about the temperature of the exhaust gases going back into the engine, we're not as worried about keeping those higher temperatures for a longer period of time.
Yeah. And another one on there is that we actually have a device that might be something familiar with what you guys see on highway. We have after treatment regeneration device, the acronym's the ARD. You might have heard Cody talk about it, but that's also there to increase the temperatures of the exhaust so that we can get to that point where we're burning all that soot up and turning into ash. So a lot of different strategies for increasing it, but when we see it more of after the combustion cycle, when we see it on the seventh injector and that separate device, I don't see us worrying too much about the exhaust coming out of it because you guys have to deal with, you have that, I don't know, it depends how big your truck is, but it can run anywhere from about 6 foot to the outside of the truck to 20 foot all the way down to the tailpipe. So we're not too worried about it because it's about 4 foot maybe to get out of the machine and into the atmosphere. So don't see too many worries about it.
All righty, very good. We had another question. Somebody else was going to ask a question.
Yes, this is Fred. Hello, Tony.
Hello.
I have some really quick questions for you. I know you've gone over this before. What are the cetane levels you would like to see normally in the fuel?
In terms of you're asking them?
Well, I'm asking, well, whoever can answer this on road cetane levels.
What is it? 34 to 36, I believe it is.
Oh, okay. I'm just right. You've told me before. Okay.
I think it was that. I'm shooting from the head. I got to look back at my notes.
No,
It's
no
not something
problem.
I memorized, but
Also,
and why can I ask why are you asking that?
well, because you asked one time, do I have a cetane or tester, and I bought one, and just for grins, I'm always testing fuel now, and just to get a rough idea, and also. If there's gasoline in the fuel, and yet one of our tests, if there's gasoline in the fuel, we put it on a metal bench and take a little lighter to it, and if it burns, okay, then we definitely know it has fuel or gasoline in it. But if
it's a little bit of a hazardous test, but okay.
Yeah, okay, I know you. I'm cautious. Okay,
Yeah,
I'm almost 70 years old, so I'm not. I haven't been that
Let her burn.
Also, if there's not enough to burn with the lighter, yet there's gasoline in it, where would the cetane level be?
That's a good question. However, email me later, and I actually have a complete worksheet on that has even the specs on it.
Okay,
So
Larry
I
will
can
do
get
that
it
for
to
me.
you. Yeah, tell Larry to send me an email, and I will send you that document. It's a PDF document talking about that and what you're looking for. So
okay,
because remember,
another...
also if I mind saying, temperature is also a factor too.
Yes, yes, that's the tool. The tool does have a thing where you add and subtract.
Yeah.
On the tool itself. Okay. Also, on your extra diesel, your urea injected into the system, and you say the NOx cannot tell the difference, would not the test for testing spray pattern and amount through a specific testing time, would that not would that not display, lead you in the direction of, to correct that issue? That you have too high a NOx and you don't know whether it's actually caused by combustion problems or extra fluid being injected. Would not the amount test and spray pattern test, would that not eliminate the problem? Do you understand?
No, well, yeah, hold on. Our
Yeah,
number
I do.
one, and Ivy, you probably and also Mara would agree that one of the biggest challenges we have on commercial vehicles, but also on light duty trucks, has been that early system. Let's go back in time for a second. Early systems actually had a light off problem. In other words, we're not getting them hot enough, because if you look at it like an old 07 Dodge, 6.7 Cummins, those DOCs and DPS were so downstream that they actually weren't reaching light offs. So therefore, if the truck did a lot of idle time and it actually pretty much didn't do hard work, it was just used for like a grocery getter. The problem was that they just never got hot. So therefore, you're permeating those catalysts with excessive DEF fluid. So one of the number one things that has fixed that issue, Fred, was running a regeneration.
Yes.
Because if that system allowed the heating of the SCR catalyst when you run a regen, then therefore that will actually burn it all out. That's why I've always made jokes in the past when we do demonstrations of regenerations where it starts smelling like Windex.
Yeah.
Because that's the excessive ammonia that you're smelling there that's been permeated in there. So that's why I questioned Ivy and Cody about this ammonia catalyst, because it can also get permeated, but does it need a heat factor? Does it need to have, which by the way, Cody, does it need to get hot before it does its job? Does it have a light off temperature it needs to reach? Don't tell me that temperature. I'm just saying, does it need to be hot? In other words.
I believe so. I believe it does. I couldn't give you exact temperatures. I
Yeah.
don't, I'd have to
No,
look
but in other
at-
words, the problem we're having is they're just running so cold, these exhaust systems. But when you got a piece of machinery like you guys have and the exhaust is right there, right next to the engine, yeah, that's not a problem. But for us, where it runs downstream down an exhaust system, it gets colder and colder. So in essence, Fred, what I'm trying to say, if I may, is the fact that one of the biggest issues of that, where the NOx sensor cannot tell the difference between NOx and also DEF fluid or ammonia, is the fact that it's just too cold, the whole exhaust system.
Now, Tony, I believe some of the Dodge products, they give a percentage of throttle position, starting from 0 all the way up to 100. And I notice a lot of the farm trucks that we run in this problem, it's spending most of its life at 0 to 10. You can tell the customer, hey, this is what's happening. I have experienced what you're talking about, but also I believe, don't they have that? I don't know what year they do this, but they actually will, in the scan tool, you can see what part of the throttle range the vehicle is operating in.
Yeah.
Is that a good indicator to help diagnose this kind of problem?
Yeah, because I know what you're talking about in that software, 0 to 10%, 10% to 20%, and so on. Yeah, where it lives most of the time. So that helps us too, to tell us, does this truck idle a lot? Does it only see part throttle? That's it, or is it always under heavy loads, like a hotshot truck? So.
Okay. Another question is, if you have a EGR cooler that is not functioning correctly, not cooling down the gases going through it, could that also cause, and you're not getting a code, could that also cause a high NOx reading?
Say that again. Oh, no. Hold on a second. If you're talking about the exhaust coming out of the engine,
no,
versus
I'm going into the, if the EGR cooler is supposed to reduce heat, and NOx is heat, byproduct of heat. If the EGR cooler is not cooling those gases that go back into the intake, could that cause a high NOx reading that you might miss? You might think that it's an oil consumption through rings or a turbo seal. And would you look, and let's say you're not getting a code, what would be the expected percentage of drop between inlet temperatures and outlet temperatures of a normally function driving down the road EGR cooler.
So you're talking about the EGT temps?
Yes.
Yes, a plugged EGR cooler can cause excessive NOx
Mm-hmm.
exiting the engine. So if
Yes,
you have an EGR cooler that's plugged, your inlet NOx sensor is going to read higher because you have too much NOx entering the exhaust. So then your SCR catalyst and the way it works with your DEF is designed to handle a certain amount of NOx. So if your EGR cooler is not reducing the NOx enough before it enters that system, that's where you can end up with problems. And like Matthew had an issue, there's Ford engines that they have an outlet NOx sensor, but not an inlet NOx sensor. And part of the issue with troubleshooting those is, well, the SCR is not converting NOx. Like I have a code saying we're not converting NOx, but is it because the SCR catalyst itself is just seeing its end of life? Or do we just have excessive NOx coming out of the engine, which in turn the SCR can't handle that much NOx, but without an inlet NOx sensor, it's a lot more difficult to diagnose. It's kind of one of those you just have to know to check, do you have a plugged EGR cooler? The good news is if it's plugged, it's eventually going to completely fail and dump coolant into your system.
Yes.
And you're going to have your answer at some point.
Now, could you look at the percentage of injection of how much NOx is being, or how much fluid is being injected? If it's consistently high, and you've uncorked the exhaust, you're not getting black smoke. But wouldn't the amount of, because you on the scan tool you can see the percentages, how much is being injected into the NOx is being injected into the system. If it's constant and yet you don't have black smoke, would that be an indicator?
Yeah, that could be. I mean, it's definitely hey, you need to check to see if your EGR cooler's plugged. And sometimes troubleshooting might not lead you to checking that. So it is something, every code and every symptom doesn't always have every possible thing that could cause it. So it would be a good, hey, I've eliminated all these things. I should check my EGR cooler. They're a high failure part.
Another thing that I saw on one of the slides, it said durability requirements 450,000 miles. Okay, I don't see our light duty trucks going that far around here. They're usually pretty. Is this a requirement? What does this requirement relate to? I saw it on one of the CAT scan slides. I mean, who says these things go 450,000 miles?
Well, on that CAT equipment. So that's where, so a DPF in general can be cleaned 2 to 3 times within its life before it's just lost its catalytic properties. The substrate only lasts so long. The precious metals coating only lasts so long.
Okay.
So on an on-highway truck, picture a semi-truck that has a 15-liter engine.
Okay.
The cleaning interval of a DPF is going to be every 200 to 250,000 miles. So if a DPF can be cleaned 2 to 3 times before it's reached its end of life on a semi truck, as long as you haven't had any catastrophic upstream engine issues, you can get up to 600 to 750,000 miles out of a DPF.
Okay.
Well, on a light duty, I don't have their maintenance manuals memorized. Your cleaning intervals are going to be a lot lower, or like the smaller the engine, the smaller the DPF, the smaller the substrate, it's only going to last for so long. So let's just say, I'm going to throw a random number out of the top of my head. A DPF should be cleaned every 100,000 miles on a pickup truck. Well, then a DPF is going to last somewhere between 200 and 300,000 miles. That also is dependent on how often it's idled, because if it's idling too much, you would then convert your maintenance over to engine hours. And as long as you don't have any upstream engine issues, right? If you have injectors that failed at 200,000 miles, well, yeah, then your DPF isn't going to last up to that 300 more than likely.
Well, but the problem I see in California is that if you cut it open, it's considered to clean it and weld it back together. A hard-nosed smog guy is going to say you've tampered with the exhaust system.
That's always been up for debate. You know, in Colorado, the same thing. But in this case, it all depends who you're dealing with. So therefore, that's more of a political, logistical thing nearby on your
Okay.
test centers, because I've been in those fights too. But that's, it all depends who you're dealing with. But let's get one thing clear, like Mara just stressed, is that, and Ivy and Cody, I think you could agree, is that maintenance has always been the issue on the life of an after treatment. And two is the equipment driven the way it's used, the way it's supposed to be driven, or the truck? There's got to be a way, because I know hotshot drivers that all they know is 0% throttle, 100% throttle. That's it. So therefore, yeah, you're going to kill it. I mean, we've had after treatment systems literally destroyed within 60,000 miles. So therefore, have we seen trucks though with the DPF and all SERs too with over 450,000 miles? Yeah, these are trucks that are driven properly. They're not abused and used, and they're also meticulously maintained. So one thing I do with my customers in the past was I read them the riot act. Either you're going to listen to me, you're not going to listen to me. But if you're not going to listen to me, it's going to cost you money. That's what it boils down to. So therefore, maintenance is the biggest thing, and also knowing what the truck or the equipment can and can't do, and how you're supposed to treat it. I mean, Ivy and Cody, would you agree?
Yeah, so on CAT equipment, it's every 5,000 hours. You pull the canister off. Ours are not welded. Ours are clamped together so that you can just pull that module off as one piece and then send your filters off to be baked, be cleaned, and that's every 5,000 hours. That's a service interval.
There you go. Mara, thanks for your input. So therefore,
welcome.
yes, I'm telling you, don't mess with Mara.
Mhm.
Mara, mess with her when it comes to after treatment. Matthew,
I did have I had a question for Cody and Ivy a little bit regarding this turbo. You talked about the two different style turbos, how the front one on the first three cylinders is kind of a small spooling up turbo, and the back one's kind of the high, the larger PSI drive, I guess. Just curious how that works in terms of my thought is I know on some of the automotive engines, Tony knows this, like on some of the Fords, they do the regeneration on the just on the one side of the engine, and so that side of the engine can wear out prematurely. My thought process was in hearing that is there more of a concern with that longevity wise on the front cylinders taking all that back pressure versus the back cylinders that aren't having quite the drive pressure, or is it so limited by the time it's got that turbo spooled that you're not going to see as much drive pressure out of the small turbo? We do see those compounds in some of the international applications. I was just curious if you could shed any light on that at all.
So far, we haven't seen any issues, regarding wear, extra wear on the engine or premature failures. We haven't seen any of that. I think for the small amount of time that it's running in these regions, because we're not putting the hours and putting the miles that you would on a light duty or a heavy duty truck or application. We're not in those regions as much as you would think. There may be, a construction equipment that gets used 15 hours and then it's put up for 3 months. So the limited amount of use of these is not, I haven't seen any premature wear or failure so far.
And I guess too, coming back to the thought that with the turbo, obviously you got the kind of the small turbo, large turbo concept there. Once that thing is up to boost, you're not going to be using that small turbo is going to kind of be not being powered. If you or not, it's not, it isn't being powered, but the main pressure is on the large turbo. If you want to put it in those terms, I guess would be some of that answer. That is that probably fair?
Yeah, well, we're running mostly single turbo setups.
Okay.
Yeah, we're running either an asymmetrical or a symmetrical turbo. There's some applications where the symmetrical turbo, just the regular twin scroll, is used because we don't have to compensate for the loss of pressure for the EGR or NRS. So we can run a symmetrical turbo and still be fine. But the asymmetrical is what they're running most in most applications. So therefore, if you're pushing, let's say you're pulling a grade with an articulating truck or something like that, you don't have that lag that you're just dumping fuel the whole time trying to get this turbo to light off. You've got good throttle response, and once you're in boost, you're not producing the NOx and stuff like you would.
Gotcha.
Is that
Thank you. Thank you to both of you, and Tony too.
Thank you. Thank you. I see Carl Schneider's on. My friend Carl Schneider, he's our Bosch instructor there. Carl, you on or you are? You may have it on, but see if Carl can say hello. I don't know if he's active there, but let's see. Is he on? Right on. I guess that's the one to say hello, but all right. Well, let's see if Carl's on. Anybody have any other questions they'd like to ask our great speakers? And Cody, once again, Ivy, I appreciate you. But any other questions? Any other comments? Issues? All right. Well, like I said, I can't thank enough. Oh, did I hear somebody? Oh, guess not. So therefore, once again, thank you guys. I appreciate you. And just a quick slide here. Yes, my infomercial. Remember, and by the way, Ivy and Cody, you're welcome to join the Diesel TG. Obviously, I know you got proprietary stuff, but you can see what we post. We got quite a bit of members now on the Diesel TG, but we need some traffic there, guys. So therefore, I would appreciate you guys, if you got any postings, any issues, anything you want to share, obviously, we welcome you to do that at the Diesel TG website. So again, and Ivy and obviously Cody, you're welcome to join us there. It's all free, guys. So therefore, it's a place just to talk about diesel and different issues or questions. And Mr. Price, again, give me an email or have you talk to me, Larry. I'll expand more on your NOx issue, but we'll definitely try to cover. I don't want you to walk out of here saying, and I also got to send you your cetane worksheet that I can give you too. So,
Okay, thank you.
with that, does anybody have any questions? Well, I guess we can conclude this, baby. Ivy, Cody, everybody else, Mara, everybody put input today. Matthew, thanks for your questions. Obviously, Mr. Price, I'm about just done. I thank you guys. Any last minute?
Thank you.
With that, I'm saying goodbye. We sign off, and Ivy, Cody, I'll send you guys an email, and we'll look forward to seeing you again in future ones.
Sounds good. See you guys. Thank you.
With that, thank you guys, and God bless. Until next time. Actually, till the 19th.